Hi everyone and welcome. In today's lesson we are going to determine the points of intersection of a straight line with an hyperbola, and those 2 points are right here and there, and basically it means it is where these two graphs touch one another. Now again, here is our straight line and its equation is gx is equal to 2x plus 4, and here is our hyperbola and its equation is fx is equal to 4 over x plus 1 plus 3. Now to determine the points of intersection and to get their coordinates, we know from our previous lessons that we can equate these two equations. Now let's do that first. So I'm going to write 2x plus 4 is equal to 4 over x plus 1 plus 3. Now here we have our equation and we want to solve for x. But we learned from our equation series that when we have an equation where there's a fraction, our first step is to turn all our terms into fractions. So the 2x will become 2x over 1, the 4 will become 4 over 1, and then we're also going to factorize this denominator because we want it to be one term. So we're going to put it in brackets because it's the same when we take out a common factor 1. And then we are going to change this constant to 3 over 1. Now all our terms are fractions, and now we can find the lowest common divider. And we look at all the denominators, and the lowest common divider between 1, x plus 1 and 1 is a x plus 1. So there we go. Now we take this x plus 1 and we are going to divide with all the denominators and multiply the answer with their numerators. So here we go. X plus 1 divided by 1 is x plus 1, and x plus 1 times 2x can be written as 2x times x plus 1. Then we write the same positive sign, there we go, and we say x plus 1 divided by 1 is x plus 1, and x plus 1 times 4 can be written as 4 times x plus 1. And that is equal to, and now we can say x plus 1 divided by x plus 1 is a 1, and 1 times 4 is 4, and then we write this positive sign, and we say x plus 1 divided by 1 is x plus 1, and x plus 1 times 3 can be written as 3 times x plus 1. And now we just got rid of all the fractions. Now we can use the distributive law in each one of these terms. So 2x times x is 2x squared, 2x times a positive 1 is a plus 2x, and then we do the same for this term. So a positive 4 times x is plus 4x, and a plus 4 times a plus 1 is a plus 4. We write down the equal sign. This 4 can be written down, and there it is, and then we do the distributive law for this term as well. So a plus 3 times a x is a plus 3x, and a plus 3 times a plus 1 is a plus 3. And now if we look at the equation we are left with, it is a quadratic equation because there's an x to the power of 2. So to solve a quadratic equation, we're going to move all our terms to one side and then simplify and then do factorization. You remember that, right? So 2x squared is the only x squared term here, so we can write it down. So 2x squared, and then we add and subtract the like terms. So 2x plus 4x is 6x, and if we take this 3x to the other side, it becomes a minus 3x, and 6x minus 3x is a plus 3x. We do the same with the constants, and we end up with a constant value of minus 3. And there is our simplified quadratic equation. Now we can waste some time to try and factorize this trinomial if you can, or you can simply try and save some time by doing the quadratic formula, and that's what I'm going to do. So here it is, just to remind you to do the quadratic formula and find our x values. We will say x is equal to minus b plus minus in the square root b squared minus 4ac over 2a. Now I already did the factorization to save some time, or the substitution to save some time, and here we are. Now we can type all of this into our calculator, and we're going to use a plus first, and then we end up with an x value that is equal to 0.68, and there's a couple of decimals that follow. But I cannot round this off yet because we still need to calculate our y coordinate. So once we do that, then I'll round off this x coordinate, okay? Then we go back to our calculator, we change the positive or the plus to a minus, and then once we calculate that x value, we will see that it is minus 2,18 with a lot of decimals following this 8. Now again, I did not round this off and I didn't write all of these decimals just to save some space. Now that we have the two x coordinates, we can easily get the y coordinates by taking these two x coordinates and substituting it into any one of these two equations. Now, which one will you use? Well, this one, of course, because it's way easier. So we will put those x coordinates in the place of x. So let's start with the 0,68. So we have y is equal to 2 times 0,68. And you have to write all those decimal values. Yes, I know. And then plus 4. And once we calculate it, we will get a y coordinate equal to 5,37. Now this one I already rounded off. And if I want to go put in those coordinates, I can round off this x coordinate now. And you will see that it will be 0,69 as well as the y coordinate, which will be 5,37. And that is where it is. Okay, excellent. How about the other pair? Well, minus 2,18 goes into the place of x, and once we do that calculation, you will see that the y coordinate is equal to minus 0,37, and I already rounded off this to 2 decimal places. So if we want to put those coordinates in, its spot will be right there, and if I round off this correctly, you will see that it's minus 2,19, and the y coordinate is minus 0,37. And that is how you get the points of intersection between a straight line and a hyperbola. See you again next time. Bye.